Hello, my name is Harshpreet Kaur. In this video, I will demonstrate my task 5.2C of embedded systems. The aim of this task is to control the brightness of LEDs using a GUI graphical user interface with sliders on Raspberry Pi. The sliders adjust the light intensity using PWM. Now let me show you my hardware setup. As you can see, I have connected three LEDs on the breadboard. These pins are connected to the Raspberry Pi using board pin number 29, 31 and 33. Each LED has a resistor to limit the current and the ground connections go back to the Raspberry Pi. Now I am going to explain the main functionality of my code. I have written this code in the Python. To create the graphical user interface, I use the Tincter library, and to control the GPIO pins of the Raspberry Pi, I use the rpi.gpio library. First, I selected board mode, which means I am using the physical pin numbers on the Raspberry Pi instead of the BCM numbering system. I assigned the three pins 29, 31, and 33 for my three LEDs. Next, I configured these pins as outputs and started PWM pulse width modulation on each of them at a frequency of 100 Hz. At the beginning, I set the duty cycle to 0, which keeps the LEDs turned off initially. In the GUI, I created three sliders using Tincter. Each slider is linked to one LED. When I move the slider, the value from 0 to 100 is passed into a function, and that value updates the duty cycle of the corresponding PWM channel. This duty cycle directly controls the brightness of the LED. 0 means the LED is off, 50 gives half brightness, and 100 gives full brightness. Finally, I added a loop to keep the GUI running until I close the window, and at the end of the program I safely stop the PWM signals and clean up the GPIO pins. Now I'm going to check this program live whether it is working or not. Let's see. As you know, our first main part is to connect the Raspberry Pi with our PC with the help of mobile hotspot. In our settings, we are going to turn it on and wait here to connect it with our Raspberry Pi. It may take some time. Now you can see our one device is connected whose name is Raspberry Pi, and our address is also coming here. Now when our Raspberry Pi is connected, we are going to open the VNC and we will type our password here to go inside the GUI interface. Here we are. Now I am going to open the terminal and I will type here cd command to go into my folder, which is task5.2C. After getting into the folder, I type the ls commands to check how many files I have created inside it. I have two files which are code_led.py and code_led.py.save. So Let's have an eye in our code, which I saved in our file, which is code underscore led.py. I use the nano command to check my code which I have written in that file. Here is our code which I explained earlier what it's the main functionality of it and how it is all working. Now I'm going to click the command Ctrl plus X to exit and I type the command python3 along with my file name to run my program. See, on the screen our LED PWM control is visible now. Here is my setup. Now I am going to move each slider one by one and point to the LED glowing. As you can see, when I move slider first, the first LED brightness changes. See, the first LED brightness changes. Similarly, slider 2 controls the second LED and the slider 3 controls the third LED. When I keep the value to the 50 on the slider, it means that it gives the dim value. And when I put the value to the 100 on the slider, the LED gives the full brightness. Let's do same for the third LED and for first one also. See, now our all the LEDs are on, and when I drop the value of the second LED on the slider to 0, the LED is off now. See, and if I do the same thing for the third LED, it get also off and only first LED remain on because its value is 100. From here it is clear that all the LEDs are directly linked with their own specific sliders. Whenever I change the value on the particular sliders, the particular LED is getting on and off according to the value which I move on the slider. It means that our hardware setup is working perfectly. In conclusion, this task successfully demonstrated how we can control LED brightness using a graphical user interface on Raspberry Pi. By using PMW and their tinker slides, I was able to smoothly adjust the intensity of each LED. This system worked as expected during testing, and this shows how hardware and software can be integrated together to make embedded system more interactive. Thank you.